Okay, every year I have students get really confused on how equilibria respond to volume and temperature changes, so I want to make sure this is super, super clear. If I have a reaction and they're all gases, or I have a reaction and they're all dissolved in water, the same concept is going to apply. So if this pen is done. If I increase the pressure of a system that's at equilibrium, which was caused by decreasing the volume, you need to look at if it's a gas, they're all gases, count how many you have. You have 2 gas reactants here, and you have 1 gaseous product here. Anytime you increase pressure of a system that's at equilibrium, you need to reduce some of that pressure. So in this case, you would always shift to the side with fewer particles, because that will relieve some of the pressure. So in this example, I'm going to shift to the right. Same thing if it was a solution. If you want to relieve some of that osmotic pressure, then you would shift to the right. Now, I always have students think, oh, you always shift to the right, or you always shift in a certain direction if you increase the pressure or did something similar. That's not the case. That's just the examples that I'm giving you are showing you that I have fewer particles on the product side, and that's why I'm shifting in that direction. If I had fewer particles on the reactant side, I would have shifted to the left, okay? If I decrease the pressure, which is caused by increasing the volume, then I would shift to the side with more particles. So in this case, I'm going to shift to the side that has 2 gas particles, which is on the left. So when I decrease the pressure for this system at equilibrium, I'm going to shift to the left to bring some of the pressure back up, since there are more particles present here, which would increase my pressure. Same thing here. I would shift left because I would bring up the osmotic pressure because there are 2 particles on the reactant or the reactant side. Okay? I don't always shift to the left. It's just that in this example, I have more particles on the reactant side than the product side, which is why I'm shifting in that direction. Okay? Now, let's talk about temperature changes. At equilibrium. Okay? Now, the temperature changes at equilibrium are different depending upon whether it's an endothermic or an exothermic process. So if I have an endothermic process where heat is a reactant, if you increase the temperature of an endothermic process, that means that you need to shift to the right to consume some of that added heat. Okay? That's always. You will always do that if it's endothermic. If you decrease the temperature, then you're going to shift to the left to replace some of the lost heat. Always. Okay? Now, let's talk about what happens if we have an exothermic process. exothermic reaction, you're going to have heat as a product. So if I increase the temperature for an exothermic process, that means I'm increasing heat on the product side here. You need to shift to the left to consume some of that added heat. You will always do that. And when you decrease the temperature, you need to shift to the right to replace some of the lost heat. You will always do that.